that equals to 0. In short, we can write here, this is minus 3 minus lambda to 0, 0 minus 3 minus lambda 1, this is 0, 0 minus 3 minus lambda, and that equals to 0. So if you solve this, so here this is the diagonal term. So this means your eigenvalues are this diagonal increase, and here this all are same. So here lambda equals to minus 3, minus 3, and minus 3. Okay, so these are the eigenvalues. So for you have to find what is the eigenvector. So what is eigenvector? So eigenvector for this lambda equals to minus 3. So you can find this is A plus 3 of identity matrix, that is into eigenvector V, that equals to 0. Okay, so here you can find this is the determinant. This if you put in here this 3i plus 3 here, so this becomes your A is this thing, so this becomes 0 entry. Okay, this is 0 to 0, 0 again here 0, here 1. This is A matrix, and 0, 0, 0. So this is the matrix, this A minus that. Okay, so this matrix and multiplied by V, and V is the eigenvector, suppose V1, V2, V3, and that equals to 0. So for that, you can find here, this is 2V2, 2V2 equals to 0, and here, what is this? Okay, and from this this line, second if you multiply by, this is V3 equals to 0. Okay, so here you get V2 is 0 and V3 is 0. So that's why your eigenvectors are, to V is equals to, this is 1, 0, 0 due to this thing. ओके, सिमिलरली फॉर सेकंड के लिए आप क्या करोगे? अब यहाँ पे तो एक ही है, तो आप क्या करना है आपको, आप रिपीटेड आइगन वैल्यूज के केस में आप ऐसे फाइंड करते हो दैट p equals to 0. So these implies you have to multiply your I minus lambda I. This is 0 to 0, 0, 0, 1, and 0, 0, 0. This multiplied by 0 to 0, 0, 0, 1, 0, 0, 0. This is square, and into V is V1, V2, V3, that equals to 0. So if we multiply these two matrices, so we get here, this is multiplied by this 0, 0, this is 2, 0, 0, 0. Okay, this last row is 0. This is V1, V2, V3. So from here, if you multiply by here, this is 2, V3 equals to 0 and nothing else. So in that case, your V is 1, 1, 0 due to this V3 is 0. Okay, so for third one, you can find what is your eigenvector. So I minus lambda I, that cube. So here square you have find. So you multiply this entry with the square matrix, that is 0, 0, 0, 0, 0, 0, and with V1, V2, V3. So that equals to 0. So here you can find. So this multiply, this is 0, 0, 0. Okay, so here you can find okay, so here what is the eigenvector is 1, 1, 1. Okay, to do this is, so these are three eigenvectors and these three are eigenvalues. Then your fundamental matrix that is equated by mx, that matrix is equals to what is your vectors are 1 into 0 into 0 into first, second vector is 1 into 1 into 0 into third, 1 into 1 into 1 into. Okay, and what is the exponential? Exponential of first eigenvalue is minus lambda, minus 3x. Here exponential of minus 3x. exponential of minus 3x. Here, the simply second one, so of course, all are same. So you can e to the power minus 3x, e to the power minus 3x, e to the power minus 3x, and here, third one, e to the power minus 3x. Okay. So this is your fundamental matrix. Then you have to find what is the value of that matrix at x equals to 0. So if x equals 0, all entries are 1. Then you can find what is m0. M0 is 1, 0, 0, 1, 1, 0, 1, 1, 1. And then if you multiply by that 2, you can find the exponential of exa. Okay, exponential of that matrix. Okay. So ठीक है, तो इस तरह से आप निकाल सकते हो. ओके, तो हम okay, so next page, okay, so so there are some common mistakes, and we are dealing that mistakes today. So okay, so first one is okay, so it is true. It is true that this e to the power if we try to find the exponential of this x of a plus b, and that equals to this multiplied e to the power exponential of that. Okay, so is it true? हमने तो लिखा है it is true, माने ठीक है, लेकिन मैं पूछ रहा हूँ आपसे कि is it true for in all cases, or there are some conditions are mentioned here. So in general, this is not equals to this thing always. If this matrices commute, then this condition hold. Okay, not always. Okay, so ये एक common mistakes है. आप generally students इसको तुरंत इस form में लिख लेते हैं. But this is true only if these two matrices are commute. Okay, so आप हम यहाँ लिख देते हैं. But in general, this e exponential of that a plus b is not equals to this multiplication of that two. So if you try to find why this happened, so if we take example, and if we take any matrix, simple matrix, we can take that cannot not commute with each other. So if AB is not equals to BA, so in that sense we write A equals to this thing and B equals to suppose minus 1 0 and 1 0. Okay, so what is the value of here A plus B? So A plus B is, if we adding these two, we get 0 0 minus 1 and 1. Okay, so if we try to find this is the A plus B matrix, and here what is the exponential of that matrix? So in this sense, we can find what is the eigenvalue. So in this sense, if we are trying to find eigenvalues, so here this is minus lambda, and here 1 minus lambda, that equals to 0. So what is the eigenvalues are 0 and 1 for that case. And for lambda equals to 0, you can find what is your eigenvector. So eigenvector is suppose v1 is in this sense you can calculate this is 1 1, and for lambda equals to 1, this is 0 1. Okay, so here you can find the eigenvectors for this matrix and eigenvalues. Okay, so what is your fundamental matrix Mx? So here you can write these are the eigenvectors. So 1 into and here 0 into 1 into, and what is the exponential of 0x? Exponential of 0x, here exponential of 0x, this is your first eigenvalues, and here exponential of 1 into x, and here exponential of 1 into x. So here, what is your fundamental matrix? 1, and that equals to 0, and okay, and here e to the power x. This is e to the power x. So this is your fundamental matrix. And what is m0 at value at x equals to 0? So this becomes 1 0 1 1. So this is the fundamental matrix. Okay, so here you can find what is m0 and what is the m0 inverse. So if you are trying to find what is m0 inverse, so m0 inverse is inverse of this matrix. So here the determinant is 1. So simply we interchange that increase. So this becomes 1. This is 0 minus 1 1. Okay, this is your m0 inverse. Okay, so what about your exponential of what is the value of e to the power exponential of a plus b? So this equals to mx and m0 inverse. So this equals to fundamental matrix is 1 0 1 e to the power x multiplied by 1 minus 1 0 1. Okay, so this equals to, if you multiply that two matrix, that equals to 1 0 e to the power, this is 1 minus e to the power x, and this is e to the power x. So this is your exponential of that. Okay, so left hand side you can calculate this thing. Similarly, you have to find what is the value of exponential of a for this matrix, what is the exponential of that this matrix, and product of that two. If these two are same, then okay, then we can say that in general this is equals to sign holds. Okay, so here you check that what is the value of ex and that this thing. The exponential of for this matrix A. So what is the value of a minus lambda I, that equals to 0. So here you can find what is lambda into lambda minus 1, lambda minus 2. Okay, so this becomes okay, so plus 1. So this becomes lambda minus 1 whole square to lambda square minus 2 lambda plus 1. This means okay. So here you can find lambda equals to 0 and 2. And for that, lambda equals to 0, what is your eigenvectors? So eigenvectors are 1, 1. And for this lambda 2, there are eigenvector is 1 minus 1. Okay, so here if we can write directly what is mx. So mx is 1 e to the power okay, so 0. So this means simply 1, and here 1, and second one e to the power 2x and minus e to the power 2x. So what is m0? So m0 is 1 1 0 1, and this is minus 1. Okay, so what is the value of exponential ex? That equals to, if you multiply uh, okay, so we have to also find what is the m0 inverse. M0 inverse is determinant is minus 1 0, so that equals to okay, 1 1 1 minus 1. So if we multiply these two, so we get here 1 by 2, 1 plus e to the power 2x, 1 minus e to the power 2x, and here 1 minus 2x and 1 plus 2x. So this is exponential of I. Similarly, you can find that matrix. Okay, so I write here directly what is the exponential of b. So you can find in same manner here what is the eigenvalues are in that sense. Uh, okay, so here eigenvalues are 0 and -1. So in for 0 के लिए आपके पास आइगन वेक्टर्स होगा that is 1 1, और -1 के लिए है आपके पास 1 0. So mx जो होगी इस फॉर्म में mx होगी 1 1 है और एक 1 0 है, आइगन वैल्यूज आर 0. तो 0 means that is 1. Okay, and here -1 e to the power -x, if you multiply here this is 0. Okay, so this is your mx, and what is m0, this is 1 1, and here 1 0 inverse. So this is
सर ए के केस में जो एम जीरो है वो 1 1 1 -1 नहीं होगा?
ओके ओके, देखिए देखिए कहाँ पे ए की केस में
m0
m0 is 1. Okay, okay, this question is 1 na? This is 1.
यस सर.
हाँ, okay, okay, correct. So here m0 inverse is okay. This is correct. ठीक. So in this sense, you can find this value, and this value is think e to the power -x, 0, 1 minus e to the power -x, and 1. Okay, power xa and e to the power xp is this matrix, and this matrix. Okay, so this multiplication of that two is not equals to this thing. Okay, that's why you can say that if exponential of this is not equals to product of these two always. Okay, if this is equal, if and
सर
only if
सर ये
बताएं।
e to the power xp के केस में भी हम लोग बीच में सारे स्टेप्स करेंगे ना, लैम्डा की वैल्यू, फिर m नॉट 0, m नॉट इनवर्स.
हाँ बिल्कुल सारा करना ही है, सारा ही करना है, सारा करना है। सारा ही करना है। हम तो आपको चूंकि इस बहुत ही सिंपल चीज है बट लेंदी है, तो हम उसमें टाइम ज्यादा नहीं डाल रहे थे, और कोई बात नहीं, एक हमने करके दिखा दिया कि ऐसे आप निकालोगे। सिमिलरली आप इसको निकाल लिया, और बी के केस में भी वैसे ही आपको निकालना है। आप कैसे पता कर पाओगे बगैर सॉल्व किए कि आपकी व्हाट इज द आइगन वैल्यूज एंड आइगन वेक्टर्स। ओके, तो यहाँ तो मैं ये तो सिंपल मैट्रिक्स है, आपने देख के कर लिया और आइगन वेक्टर्स देख के निकाल ली, बट यू हैव टू कैलकुलेट ऑल दोस थिंग and then multiply, and you have to show that this product of these two, whatever the value of, if you product of that equals to whatever the value, this is not equals to that thing. Okay, ये आपको पूरा शो करना होगा। ठीक है, ये तो हमने एक एग्जांपल लेके आपको से बताया कि आप अब एक्सपर्ट हो कि कैसे हम एक्सपोनेंशियल मैट्रिक्स हम निकाल सकते हैं बाय यूजिंग फंडामेंटल मैट्रिक्स। ओके, तो इन ये सिर्फ ये बताना कि कॉमन मिस्टेक्स हो जाती है स्टूडेंट से कि एक्सपोनेंशियल ऑफ e और x ये है, तो इन्होंने प्रोडक्ट ऑफ दैट टू लिख दिया, बट दिस इज ट्रू of course, but if these two matrices commute to each other, वो तभी होगा, अदरवाइज ऑलवेज ये कंडीशन होल्ड नहीं करती। तो ये कॉमन मिस्टेक्स कभी कभी स्टूडेंट्स कर लेते हैं, इसलिए हमने एक एग्जांपल देके आपको बताया कि आप ये पहले चेक कर लो कि ये दोनों कम्यूट कर रहे हैं या नहीं कर रहे। अगर वो कर रहे हो, ए बी इक्वल्स टू बी ए, ओके, देन इन दैट केस यू कैन राइट डायरेक्टली दैट इक्वल्स टू दिस इनटू दिस। बट अगर ये नहीं है तो ये आपकी इक्वल नहीं होगी, तो आपको ये अलग आपको फाइंड आप इस फॉर्म में आपसे नहीं लिख सकते। ओके, ऐसे और भी कुछ कॉमन मिस्टेक्स होती हैं, हम उसको भी डिस्कस कर लेते हैं। ओके, सो नेक्स्ट पेज okay, so we have already learned how to solve this system of differential equation. So we learned how to solve this dy over dx that equals to ay, where this a is constant matrix. Okay, so unfortunately, unfortunately, uh, there is no general solution, no general solution method for if our system is dy over dx that equals to this is a function of x and y. Okay, so here if we uh, mark this equation as star, and what is a ax is a non-constant matrix. Okay, okay. So in particular, yx, you have known that if this thing, so you can write a solution of that to dy over y this dx. So log y equals to, okay, so you can write this exponential form. So you can write x of ax, and there are some arbitrary constant c. This does not solve your equation star. Okay, if you take this type of form, and this solution is even fail, uh, this fails in the scalar case. Okay, so if you take an example, simple example, if you take sine function, so this is the solution. So
सर स्केलर केस मतलब
scalar case matlab ki this means not a vector quantity, this arbitrary constant means one dimension. Okay, here this is the n dimension matrix n cross n. Okay, the scalar one, this means this is dimension one. Okay, so if the solution of this scalar solution, this scalar equation, and we can write simply dy by dx equals to sin xy. Okay, here this is your scalar one, sin x. Okay, so the solution of this is given by you know that what is the solution. So this solution is, you know that this equals to e to the power minus cos x and arbitrary constant c, but not in this form. This is not e to the power x sin x constant c. Okay, this is not a solution. If we take in this form, this is x of this ax, this is sin x, so this is not a solution. So this is even fail in the scalar one. Okay, so in general, you can say that this is integral of here we put here integral sign. Okay, so that then in that case this equals to minus cos x. Okay, so if we take the okay, so if we take an example, and you take this is likewise, you can say this is this yx, that is this yx, this equals to, we can write integral of that if we take this as ds with constant c. Okay, so here this is the not solution, this is the fail in even scalar case. So you put here this is the integral of that. Okay, so now this case is true for, of course, in scalar case, but in if the dimension of that is greater than one, then this solution is also failed. So you can write here this is also wrong solution. Formula for the given equation star. Okay, so this formula, of course, this is true. So this formula is only valid. This is only valid for scalar case that is when the space dimension is 1. Okay, so if you try to see how this solution is failed for if this is a space dimension is greater than 1. So in next page we can take an example and try to see how this is not exist for the space of dimension greater than 1. So in next page we take an example. And if you consider this system of linear differential equation of dimension greater than 1, so here we put here this is minus 1 and this is of y. Okay, so here there are two dimensions and there are the component of y1 and y2, and what is the initial condition is given, that is equals to 1 0. Okay. Okay, so this is 1 0, where your matrix is equals to 1 0 2x minus 1. Okay, so solution, this initial value problem is y. To solve this, the solution of that is this thing. You have checked this is correct or not. Okay. So solution of this initial value problem. Okay, and x. So this equals to x integral of that, and here 0. So integral of that is 0, and 2x square by 2, that is x square, and this is minus x. Okay. So integral of this with matrix that is 1 0 1 0. Okay, so exponential of that into multiply by this matrix, so this equals to exponential of this, so you can find this equals to half x minus half x e to the power minus x, and the second column is this thing, and multiply by 1 0. Okay, so this equals to, finally we can write directly the results. यहाँ पे हम सिर्फ आपको हम रिजल्ट दे रहे हैं, आप इसे वेरीफाई आप खुद से कर सकते हो, एक्सपोनेंशियल मैट्रिक्स हम कैसे निकालते हैं। तो आइगन वैल्यूज आइगन वेक्टर से आप निकाल लिया, फिर मल्टीप्लाई कर लिया, एक्सपोनेंशियल ऑफ दैट, द सॉल्यूशन ऑफ दिस इज 2. ओके, सो फ्रॉम equation 1 and 2 we get this is exponential of this thing equals to that, and solution of this matrix is this thing. If we compare these two are not same, these two are not same. That's why we say that this exponential of integral 0 to x as ds with arbitrary constant does not give the solution. Okay, so in general, this is true. This is true, but in that case, when this a is scalar one. Okay, but for if this is dimension of higher in dimension, this is not true, because you can find the what is the solution of that by usual method, and here you can find the exponential of that, and these two are different one. So that's why you can say that this 2 is not the solution of this given initial value problem. Okay, so there is a one more uh, result we will discuss with you. So in next page, there is someone one more common mistakes, that is what is the value of, if we write e to the power exponential of say any bx, and we have tried to find the differentiation of that, this is prime. Okay, so usually you can write this is b prime, this exponential of whatever this, and e to the power bx, you can write this thing. Okay, so this is true. Okay, this is true, this condition holds for scalar functions. Okay, when bx scalar. Okay, and if we take e to the power say x with matrix A, and if you try to find the differentiation of that with respect to x prime, so you can write here a e to the power exponential of that, or you can say exponential of that into a. This is true. This is true for if your matrix is constant. Okay, but in general, this is not true for non-constant matrix. Suppose we take this is bx, and you have to retain this e to the power, that is your matrix bx, and you have to find the derivative of that. So this is if you take okay, so we can write this is neither this b prime this exponential bx, okay, nor in this form. Okay, so if this is a matrix, then this condition doesn't hold. This means this is not equals to that thing and that thing. Okay, so if you have to check that how this is correct or not, so you take any matrix bx, which is a function of x. So we take a simple matrix that is 0 minus x. Okay, and you find what is the value of exponential of that. So exponential of this matrix is e to the power x of x e to the power x. You can try to find this is correct or not, And this is the same example. In previous example, we can consider this thing, okay, where we integrate that matrix and we find the exponential of that. So same value we can consider here. So this is e to the power minus x. Okay, and hence, if we try to find what is the value of exponential of this matrix, and we try to find the derivative of that, so we have to differentiate all component wise. So this is e to the power x, and if you differentiate, this becomes 0, and this is minus e to the power minus x. Differentiation of this, if we recombine the terms, so this becomes x plus 1 by 2 e to the power x plus x minus 1 by 2 to the power minus x. Okay, so this is the derivative of this matrix. Okay, so if this matrix is equals to, if we try, if we have find this b derivative of this matrix with multiplication of that, or this with derivative of that, if this equals to this thing, then we can say that okay, this is correct for all cases. Okay, but here you will see this is not equals to that matrix. Okay, so what is your b prime x e to the power bx? Basically, b prime means derivative of with respect to x. This is 1, 0, 2x minus 1 with e to the power bx. This is half x e to the power x minus half x minus x, 0 to the power minus x. If we multiply these two, you get this value is e to the power x, and this is 3 by 2 x e to the power x plus half x e to the power minus x, and this is 0 minus e to the power minus x. Okay, so this is the value. And if we find this value, second one, e to the power bx with b prime x, so this equals to multiply this term. So e to the power bx is half x to the power x minus half x power minus x, 0 to the power minus x with b prime. B prime is 1, 0, 2x minus 1. So in that sense, if you multiply these two, you get e to the power x, and here 1 by 2x e to the power x plus 3 by 2x e to the power minus x, and here 0 minus e to the power minus x. Okay, so look here, in these three cases, first one is this, second this, and third this. Here this e to the power x, e to the power x, e to the power x. Here 0, 0, 0 minus x to the power x. Okay, so these three entries are same in first, second, third equation, but here in last this position 2, 1 position is in all cases these are different. So this is not equals to this thing, this is not equals to this thing, and of course these two are not equal. Okay, so if you multiply, means these two are not commute to each other. Okay, so if this matrix is a function of x, then this condition doesn't hold. Okay, so you can write here these all three matrices. So this is the result. Okay, so these are some common mistakes, and in future we will also discuss if there are any problem. So we will also discuss about that problem. Okay, so now there are some theorem which is based on the fundamental matrix. If okay, so first of all we define what is the solution matrix, and that solution matrix satisfies your matrix differential equation. So in next page Okay, so this is the part of fundamental matrix, so that's why we give a title is fundamental matrix. Okay, so construct a matrix whose columns are solution of this y prime that equals to xy, where x belongs to this interval I, where what is y is basically column. This is n vector, and ax, where x belongs to R, is n cross n matrix. Okay, so you can write this in other words. We have considered a set of n solutions of the system first and define define a matrix that is capital M, whose columns are these n solutions. Okay, so such a matrix is called a solution matrix, and it satisfies the matrix differential equation. Okay, so that's why your M prime, this satisfies your matrix equation. This equals to this thing when this x is belonging to that interval. Okay, so the matrix M is called a fundamental matrix. It is fundamental matrix for the system first if the columns are linearly independent. For that sense, this matrix is said to be fundamental matrix. Okay, this is your fundamental matrix. Okay, so if we associate with system first, a matrix differential equation, we can y prime equals to this, we associate this. So obviously this n is solution of this equation star. Okay, so when the mx, this condition holds when the matrix Ax is independent of x. Okay, So this is the solution of that. So here you have to find what is the there is basically a theorem. There is a theorem. There is a result. So next page we write what is your theorem and try to prove that theorem. So in next page, if you mx when x belongs to that interval, this be a fundamental matrix of the system, that is y prime equals to ay when x belongs to that interval, of course, such that this fundamental matrix when x equals to 0, when this equals to identity matrix. Okay, so when this is the fundamental matrix of this system, and like this, given this m of 0 that equals to identity matrix, where this A is a constant matrix, there is a constant matrix. So here, okay, so here, this I denotes, here I denotes the identity matrix and okay, so so if this is fundamental matrix and this value equals to identity, then basically this theorem says that then this M satisfies the relation, that is M of x plus any s, which is a real one, when x belongs to R, s belongs to R. So this plus this equals to product of that two. This is the result when this M0 be the identity. In that sense, you M of x plus s, when s and s are real, so for all x and s belonging to real R. Okay, so this is the theorem. When this is the fundamental matrix of the system of equation, and when this M0 be the identity matrix, when this is the identity matrix, in that case, we can write this M of x plus s, this can be written as mx into ms, okay, for any real s. So this is the theorem, and you have to prove that theorem. So, okay, so we will prove this theorem in next class. Okay, no, अभी कर सकते हैं time. So proof here we use by the uniqueness theorem. There exists a unique fundamental matrix. Because the solution is unique, so you get unique matrix, that is mx, for the given system, such that you take here this condition holds M0 be the identity matrix. And here you know that this mx is also satisfies your matrix equation. So this satisfies the matrix equation. Okay, say this is question number 1, and say this is, you have to prove that this 2, and if you take matrix equation, suppose this is 3. Okay, so here if we define for any real number, say s, and here we take what is the ux, so you can write this ux, and that is basically you can define, you have to find this thing. So you define what is the value of mx plus s, and for any real, if s be the fixed one, if for any if you define this thing, then what is the differentiation of that? So this equals to differentiation of this function. Okay, and here you know that this m, this satisfies your matrix equation. So this m y prime, that equals to this thing. This means m prime equals to am. So this satisfies your matrix equation. So you can write here. Okay, so here we can write this equals to equation 3 is like this. This satisfies matrix equation, means m prime equals to am. Okay, so this satisfies this equation. So here, what is the value of m prime? So m prime is am. So that's why here you can write this is a, and m means x plus this thing. Okay, so because this fundamental matrix satisfies this matrix equation, so that's why this is equals to this thing. And here you define this mx plus s, that equals to u. So this becomes a of ux. Okay, so hence u is the solution of the matrix equation 3, such that, so hence you can write u is the solution of the matrix equation 3, such that this, what is the value of u0? So if you try to x equals to 0, so this equals to m of 0 plus s, and this is simply ms. So this is equation number, suppose 4. Okay, so okay, in next page now we define this term, suppose z. Okay, so this is z0. If we define suppose, now we can define here. So if we define what is this function, which is mx, this is from equation number 2, is product of these two. So if we define this is say zx, if we define this term for all x and s belongs to R, and let us note that this z is solution of this equation 2. So here clearly, what is the value of z0? You have to find already u0, and if these two are same, then you can say that this is the unique solution. So this, what is the value of z0? Z0 is m0 and ms. And what is the m0? M0 with the identity matrix, it is given that, and this is ms. This is simply ms. So this is equation number 5. Okay, so here from equation 4 and 5, you see that from equations 4 and 5, there are two solutions, which is one is u and another is z of equation 3, such that there are two solutions and that two are same. So you can find here this is same as this thing. So by uniqueness theorem, we have that this ux and zx, both solutions are same. Okay, so that's why you condition the relation to holds. Okay, so आज इतना ही करते हैं। जैसे आप पढ़ लेना, अगर कहीं कंफ्यूजन होगी तो आप हमें नेक्स्ट टर्म पे आप हमसे डिस्कस कर लीजिए। ओके, सो मेरे ख्याल से टाइम ओवर हो गए हैं आपके, तो आज इतना ही करते हैं। ओके, सो इन नेक्स्ट टर्म वी विल डिस्कस। ओके,
थैंक यू सर।
Thank you, sir.
थैंक यू सर।
थैंक यू सर।